So there was a really good question about how to find the second angle if you have the first angle when the first angle is not in the first quadrant. So maybe it's easy, like if you have an angle right here in this quadrant, to find the other angle that has the same sine, cosine, and tangent, because maybe you know the method using all silly turtles crawl. But let's look at a method to find the opposite, or the second angle that has the same sine, cosine, or tangent, even if the angle is not in the first quadrant. So the book gives this explanation, and I thought that maybe this part is a little bit hard to understand, but I think the pictures that they gave are really good. This is the picture for two angles that have the same value of sine. This is the picture for two angles that have the same value of cosine. And this is the picture for two angles that have the same value of tangent. Not only do these two angles have the same value of sine, but both of the sine values are negative. Not only are these two angles do they both have the same value of cosine, but both angles have a negative cosine. And not only do these two angles both have the same value of tangent, but they both have a negative tangent. So that's what these pictures are kind of showing. And you can see the pattern, right? Like these two angles are reflections of each other about the y-axis, right? So if you reflect this one about the y-axis, you'll get this one, and you can see that the y-coordinate for both of these 2 points is the same y-coordinate, right? The x-coordinate is like the negative of the other, but the y-coordinate is the same y-coordinate. Guess what? The coordinate of these points on the unit circle are cosine theta, comma sine theta. So for here, we see that the y-coordinates for both are the same. That means that the sine value is the same. For this one, you see that it's reflected about the x-axis when the cosine value is the same and the cosine value is negative in this case. So you can see that, like, for the coordinate for this and the coordinate of this, the x-coordinate is the same, and if the x-coordinate is the same, that means that the cosine of both is also the same. How can you tell that this is a negative cosine? Because you can see that the x-coordinate is to the left of the origin, so that means it's a negative value, so of course the cosine value is negative. How can you tell that this diagram is showing two angles with negative sine values? Because the y-coordinate is negative. Sine is the y-coordinate of the point that's on the unit circle. Now, maybe the tangent is the trickiest one. Tangent has the second angle with the same tangent value in the completely opposite direction. You can see that, like, this one's pointing this way, this one's pointing this way. You say it's not a reflection about the x-axis, it's not a reflection about the y-axis. Actually, this is a reflection about both axes. So first you reflected about the y-axis, it ends up here. Then you reflected about the x-axis, it ends up here. Okay, so you're actually doing two reflections, about the y-axis, then about the x-axis. You could also do it in the opposite order. Do the reflection about the x-axis and then the y-axis. Either way, you're going to end up with an angle that is like in the completely opposite direction, 180 degrees different. Okay, and so why is tangent like that? It's different than this one, right? So, like, remember that the value of tangent is not related directly to either the x or the y coordinate. Actually, tangent, remember, is equal to sine divided by cosine. So it's actually equal to the y-coordinate divided by the x-coordinate. And so, like in this case, we can see that the tangent value, since it's the y-coordinate, which is positive, divided by the x-coordinate, which is negative, you can see that the tangent value is going to be negative, right? And the other quadrant, which would have tangent values that are negative, would be this quadrant, because this quadrant has positive x value and negative y value. So these two quadrants, this one and this one, would have negative tangent values. Okay? Now let me tell you a different way to do it. Remember, all silly turtles crawl tells you the quadrants where certain trigonometric functions are positive and where they're positive. And you could use all silly turtles crawl to see which quadrants the trigonometric function takes on a negative value. For example, for sine, this was the one for sine, right? All silly turtles crawl. So sine is positive here, sine is positive here. So that means that sine is negative here and negative here. So if you end up with one of the angles here, either this angle or this angle, you know that to find the other angle with the same negative sine value would be in the bottom quadrant, just like this one. And same thing with this, all silly turtles crawl. So you know that all and crawl are the two quadrants that have cosine positive. So cosine is negative on this half of the quadrants, right? And so cosine is negative here, cosine is negative here. So if you happen to find an angle, either this one or this one, you can find the other angle that has the same negative cosine by reflecting it over this axis, right? Because all silly turtles crawl, you know that these two are positive cosine values. Here they're both negative cosine values. And finally, all silly turtles crawl, you know that the tangent values are positive in the first quadrant and in the third quadrant, so they're negative here and here. So if you happen to get an angle here, you know that the other one that also has a negative tangent would be here, and vice versa. Okay? I'm going to show you one more way that maybe would be a good way for you to interpret it. There's, I already told you two different ways. You don't need to use both ways. Just pick the one that you think is easier. Either the one where you think of the cosine and sine values as the x and y coordinates of the point on the unit circle. That's the first method. Second method would be using the inverse of all silly turtles crawl. Maybe one of the things that to do that, it might be easier if at the beginning of the exam you drew out, three diagrams here. This one's sine, this one's cosine, this one's tangent. Say, okay, all silly turtles crawl. So these two are positive, these two are negative. All silly turtles crawl. So this one's positive, these two are negative for cosine. For tangent, all silly turtles crawl. So these two are positive and these two are negative. If you draw that out, maybe that'll help you be able to find the second angle that has the same sine, the same cosine, the same tangent. Remember that you're always finding angles that are reflections either about the x-axis, about the y-axis, or about the x and y-axis in the case of tangent, right? So when are you going to find each one? Well, for sine, you're going to look for reflections about this axis. For cosine, you're looking for reflections about this axis, and for tangent, you are doing a double flip. And remember, it's going to either go from the second quadrant to the fourth quadrant to the second quadrant, the first to the third, or the third to the first, right? You're reflecting completely into the opposite quadrant. Okay, and then I'll give you one more way of thinking about it. This is for people who are very comfortable with, what a sine function looks like. Like, first we're going to draw a sine function. Well, that's too fat. Okay, first we're going to draw a sine function. It looks, let's see. Sine function looks kind of like this, right? And it's going to go up, and down, down, and up. Okay, that's sine function. Cosine function is going to look similar to that, but it starts at 1, and the midpoint is at its minimum, and these 2 points would be in the middle. Okay, so cosine looks like that. And then finally, tangent, remember, is kind of a weird looking function. It's got asymptotes at, I think, pi over 2. Right, and then every pi after that, it's got an asymptote. So here you would see something like this, right? And basically this here is 2 pi, right? This is 2 pi, and this is 2 pi. Okay, so once you draw these diagrams out, you can kind of tell now where the angles that have the same sine values, same cosine values, same tangent values can be located, right? So let's say that you find a angle that is here, and it has, you want to find the other angle that has the same sine value. Well, just by drawing a dotted line here horizontally, you can see that the other angle that has the same sine value as this one is right here in the first quadrant, right? The first quadrant is in the from 0 to pi over 2, right? So like if you start with this one, you know that the other angle that has the same sine value is here. What if you had this angle? Where is the other angle that has the same sine value as this one? Well, you just draw a horizontal dotted line, and then you can see that the second angle would be here. Okay? Same thing with cosine. You could just like say, okay, my angle happens to be here. Where is the other angle that has this same cosine value? Draw a horizontal line. You can see that the angle is here. And when I say the angle is here, I mean actually it's the x-coordinate here, right? So the x-coordinate is the angle. The y-coordinate is the value of cosine for that angle. So, and actually this is basically doing a reflection, just like we were shown before. It's a reflection about the x-axis or y-axis of the unit circle. So like, for example, if you know that this angle here was like, I don't know, 11 degrees, you know that this angle here has to be, and remember the middle x value here is 180 degrees, so it's going to be 180 minus 11 degrees, right? And then like this one here, let's say that this angle here was 100 and, or like let's say it's 200 degrees. Then we know that this one here is going to be like, this 200 is 180 plus 20, so this one would be 360 minus 20, so it would be like 340 degrees, for example. So the distance from, you know, here to here is the same as this distance from here to here, and the distance from here to here is the same as this distance from here to here, because it's a reflection, right? So that might help you get the, you know, before we were looking at these nice pictures here, it might tell you the formulas to go from this angle to this angle, right? They give you these kind of really hard to remember formulas here. Pi plus blah, 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 2 pi minus blah, 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 pi minus whatever. Maybe the best way to, you know, not have to memorize those is to think about maybe this. You know, I think there's two ways to do it. One is you could like draw the picture of the unit circle. The other way is you could look at these sine or cosine diagrams. Both of them would kind of show you how to reflect them. And maybe it is also easier to think about it in terms of degrees. Maybe derive the formulas, you know, pi minus theta. You could derive that maybe easier with degrees, saying 180 degrees minus theta, and then figuring out that the other one is whatever, using degrees, because, you know, maybe it's a little bit more intuitive than using radians. Okay, so so we could do the same thing here if we had the unit circle instead, and we're looking at sine here, right? So if we said sine of 11 degrees is like here, right? What other angle has the same sine as 11 degrees? And so sine, we know, is going to be a reflection about the y-axis because all the reasons we've said up until now. And so that would be this angle here. And so we can see here that, okay, if this is 11 degrees, then we know that this is also 11 degrees. And so how could we find this angle, which is the name of the purple angle? It would be 180 minus 11 degrees. Or in radians, it would be pi minus theta, right? If it's theta 11 degrees, it would be pi minus theta, or you could say it's 180 degrees minus 11 degrees. Okay? So the reason why this went on so long is because I'm trying to give you multiple ways of looking at it, but you only need one way that really makes sense. Oh, last of all, let me touch on tangent a little bit. Tangent, you're going to have something similar here where you say, oh, my tangent value is here. What are the other tangent values, or what are the other angles that have the same tangent value? You can sketch this horizontal line, and you can say, oh, I have one here, I have one here, and then you figure out which one's in your interval, and then you can see, oh, well, this angle here, let's say that this was, I don't know, 100 and This would be 270, so maybe it would be like 250. Let's say that's 250 degrees. Right here it's 270 degrees. So you say, oh, I'm 20 degrees from the asymptote to the left. So this would also be 20 degrees from the asymptote to the left. So it would be 90 minus 20. So this would be 70, for example, right? And then maybe you could think, oh, okay, so how do I figure out where the others are? All I need to do is jump by 180 degrees every time. Okay? Maybe that was confused you more than it helped. Come by and ask me questions if you are confused.